Okay, in this lesson I'm going to walk you through some time value of money calculations. I'm going to start here in Chapter 5 and go through the 5 different examples of present value, payment, number of period, rate, and future value. This f of x function right here, this is where we're going to get a lot of the calculations. The main idea here is, as I know 4 out of the 5 values I can solve for that 5th value, whether it's future value, number of periods, rate, present value, or payment. But once I click on that f of x, I'm going to go over to financial, and we're going to do the first one on page 127, which is a future value problem. So I'm going to click in here. If I type the letter F, it should bring me right to it. So here's future value. I'm going to click on OK. In this type of problem, we're told that the interest rate is 20%, so I'm going to put in 0.20. The number of periods, this occurs for 10 years, and this implies that it's an annual rate. If for some reason this had been monthly, we would have taken this number and divided by 12, and the number of periods 10 years times 12 to get it compounded monthly, but this is just an annual example. There's no money added to the account at the end of the time period. And finally, our present value is going to be a negative $1,000 because Excel logic, you invest $1,000, but you expect a positive cash flow back to you in the future. So that matches up with the $6,191.74. So I'm going to click on OK there. We took in the wrong one here. So let me just cut and paste it right here. So now we're good. So we got the future value problem right there. Just going to highlight that cell there. All right. Number of periods on page 128. We look at this one, and this is often a good calculation. Say, how long would it take me to pay off my credit card based on a certain interest rate. So I'm going to go back to the f of x again. Look under financial in the categories. If I type in the letter N, kind of scroll down a little bit to NPER, hit OK. We're told the interest rate is 10%. There's no payment. The present value is a negative $9,330, and the future value is $20,000. So based on that, it would take us 8 years for the number of periods to invest $9,300 at 10% in order to have a positive $20,000 in the future. So I'm going to hit OK there. Our next one on page 128 is the interest rate. What rate of return would we receive if we invested a certain amount of money and receive a future value amount? So I'm going to go to f of x, and we're going to find rate. So type in the letter R, takes us right to rate. I'm going to hit OK. Our number of periods in this case was 30 periods, or 30 years. There's no payment added to the account. We could leave it blank. The present value is a negative $34,946, and we'll receive a positive $800,000 in 30 years from now. So that tells us that the interest rate is 11%. So if we click OK, we got 0.11. One thing I'd point out for finance, it's usually a good idea to make sure to move this to 4 decimal places just to be on the safe side. So especially if you're going to do net present value, internal rate of return in the future, you want to make sure that it doesn't round up or round down for this answer. All right. Next one with present value. The common idea of present value, it's the foundations of finance, or in our course, is what is something worth today? If you have something that's worth $10 today, and it is today, that is worth $10. If you had to save a certain amount of money for the future, we'll do just a simple problem and I'll cancel it out. But let's say that, let's go to present value PV, and say that I needed $1,000 5 years from now. I could earn 10%, but 0.10 5 years, and I need $1,000 5 years from now. Well, what that says is I'd have to invest $620.92 today in order to have that $1,000 5 years from now, assuming it can earn 10%. So that's a present value problem. When we get to net present value, we'll use this too in the sense of cash flows for a business. But what I'm going to do is I'm going to clear this out, and we're going to do the example on this page for a present value of an annuity. By definition, a present value of an annuity, like really a car payment, is annuity. You think it's an equal stream of payments. But we want to know how much we have to put into account today in order to make sure to be able to take out a certain equal amount of stream of cash flows over a period of time. So I'm going to go back to PV for present value. And we go right there, so hit OK. And in the example, we're going to look at the one on page 137. This is a present value of an annuity due. So we're told that the rate in this case is 10%, put in 0.10. There's 20 years, and then the payment, we would receive a positive $100,000. 100, 1, 2, 3, 1, 2, 3, and the future value amount is going to be 0. Now, right now, as I have it now, this is a regular ordinary annuity. It means that the payment happens at the end of the time period. And you'll notice the $851,000. But when I change the type to 1, that becomes an annuity due. And what an annuity due means is just that the payment happens at the beginning of the time period. You think of financial situations, rent happens at the beginning of the month as opposed to you making your car payment at the end of the month. So we hit OK there, and our number matches up, so we'd have to put in $936,492.01 in order to receive $100,000 at the end of every year for 20 years, assuming we earn 10%. The last calculation on page 139 is a payment example. This is good for figuring out a mortgage payment, a car payment, but we'll go to f of x, and we're going to hit find PMT. So I just typed in the letter P, it brought me to PMT. I'm going to hit OK. The rate we're told on this one, and this was a 25-year mortgage, and it looks like our interest rate here is 8%. So most people make mortgage payments monthly, and this is a 25-year mortgage. So we're going to put in 0.08, but we're going to divide that by 12. The number of periods was 300. So we have, if you take 25 times 12, get the 300. The present value is the amount we borrow. So somebody gives you a loan, a positive cash flow, but you turn around and make negative payments over a period of time. So put in 100,000, and we'll leave the future value blank, and you can see that matches up to our textbook of $771.82. So I'm going to hit OK here. So again, to summarize, for finding out future value, number of periods, rate, present value, or payment, as long as you know 4 out of the 5 values, you can solve for that 5th value. And again, Excel is a nice little tool to use to help us calculate these time value money problems. One last example, let's put one in here on page 140. This is with effective rate. So let's just type effective rate. But in Excel, it's going to be EFFECT. So let's go find that function. I'm going to follow the example. Let's say that you had taken out, borrowed at 12%, but it's compounded monthly. If I go into f of x and find effect, so I'll hit OK. I'm going to put in the interest rate at 0.12, and the number of periods is 12. And again, we kind of see that there, it's 12.68%. So the true effective borrowing cost is 12.68%, not 12%. So it allows us to make comparisons, especially if you're borrowing against your credit card. It may say 18%. Well, the true effective annual rate might be 19.6%. If you take out a car loan at 7%, the true effective annual rate will be a little bit higher. Again, it allows us to make a comparison, especially if you were shopping around between 2 CDs, one CD paying 3.95% compounded monthly and another one 4% compounded annually. Well, probably you'd want to go with the one 3.95% compounded monthly, because perhaps that pays a little bit higher rate of 4.02%. So that ended our lesson on time value money calculations, and I'll stop here.